So in this video, we are going to implement a problem called Caesar's cipher. So Caesar's cipher, you can have a look at Wikipedia. It's a popular problem where what happens is that a particular string is given. So for example, any particular string is given, and then you have to encrypt it, and you have to encrypt it in a very simplistic way. And that simplistic way is that you simply shift the characters of the alphabet by some amount. So something like this. So let's say you have a string s, and it is, let's say, a b c, and it's, if somebody tells you that shift it by one character, then your answer is going to be b c d. Yeah, so a becomes b, b becomes c, c becomes d. That is one thing. And okay, and if somewhere, let's say, x y z is there, then x will become y, y will become z, and then z will not go further, z will again go back to the first character, so z will become a. So you can understand that some sort of a rotational thing is there, right? So a, that shifting from a to b, b to c, and then z to back to a, something like that. So this is what you get when you do a shift of +1. Similarly, you can do a shift of +2, shift of +3. You can do a shift of +13. You can do a shift of +23. What happens when you do a shift of +26? You can see that firstly, let's see +25. If +25 is there, then essentially you are saying that uh, the first character becomes the second last character, because if 26 is there, then so firstly you understand that after every 26, so if something repeats, so if somebody rotates by 1, then you become a to b. If somebody rotates by 2, then you become a to c. Similarly, if somebody rotates by 26, then a will again become a, b will again become a. So if somebody does 27, then this 27 is equivalent to 1. You understand? So now you can understand that it is in the pattern of modular arithmetic, which means that 27 is equal to 27 mod 26. Why 26? Because 26 is the size of the alphabet. Okay, which means that if somebody says that okay, 55 plus 55, then essentially you will do 55 mod 26, and 26 mod is like 3, right? So it will be equivalent to 3. So the idea, so the idea is pretty simple, right? The idea is pretty simple that after every 26 characters it is going to be repeated, and that's what, and this mod thing is what? This mod thing is simple remainder, right? So if you're not comfortable with mod operator, then simply the just a remainder is in JavaScript, that is same. So if this thing is 3, then that is fine. But if somebody says you that that shifted by -1, then what do you do? Essentially, when you do -1 mod 26, then you get 25. So it is equivalent to 25. Okay, so either somebody says you plus 25 or somebody says you -1, both are equivalent. Okay, but for our purposes, nobody will give you a negative thing. In fact, only positive numbers, positive shifts are given. That is the first requirement. The second thing is that the string is given, it can be a sentence, and it will have no special characters, but it will have just uppercase letters. Even lowercase letters will not be there. All the letters will be given as uppercase letters, and at most there can be spaces. So you can understand that if a sentence is there, then there are many words. All the words are in uppercase, and at most there can be spaces here and there for separation of words. That's it. And some uh, some number will be given. By that you have to rotate. Okay, and what is that number? So any number, let's say something like let's say something like so here you can see that this is so like for example, this A is transformed, B is transformed, and how this is transformed? This is transformed based on what is the size, and this is also called a rotational transformation, right? But it is why rotational transformation? Because let's say you are transforming by 2, then A becomes C, B becomes D, in that sense, right? And then Z becomes back to B, because Z plus 1 plus 1, Z plus 1 will be A, and then A plus 1 will be B, right? In that case it is also called rotational transformation, but it is called Caesar's cipher. Just I don't know, it is assumed that in the older times Julius Caesar used it in private conversation, so that is fine, but the idea you understand. So let's see, if somebody gives you this string, and then we have an implementation where you pass s, and let's say you shift it by 1. The second argument is the amount by which you have to shift, and that will always be a positive number in our case. You can implement for negatives, but for this example, this question, there will be simply some positive number will be given, right? And you can see that if I run this, then I get shifted by 1. A becomes B, B becomes C, C becomes D, and then X, Y, Z becomes Y, Z, and Z again becomes back to A. And again, in a similar manner, if you see that if you shift it by 2, then you will get something like this: C, D, E, Z, A, B. Okay, and now what happens when you shift it by 26? You can say that it will remain the same: A, B, C, X, Y, Z, right? And what happens when you shift it by 25? So you can see that you are getting Z, A, B, W, X, Y, something like that. And now you can understand that this transformation which was happening, like this A is going to X. So this is essentially you are saying that this is I think 24, right? So I think it is 23, because you can see that on 25 you will get to Z. So on 23 you will get to X. So for example, if I get to do 23, then yeah, A, B, C becomes X, Y, Z. So A, B, C becomes X, Y, Z. So in that manner you can, but that is the point. This is sort of cyclic rotation, right? Now there is one more part to the question, and the simple thing is that what if I don't give anything? What if I don't give anything? If I don't give anything, then it will be considered uh, 13. It will be considered as by default it will be considered as plus 13. So 13, which means that you assume that the second argument is 13. It's just the way it is. In fact, there is a popular system known as rod 13, which is similar to this just Caesar cipher with that n is equal to 13. The rotational is plus 13. So in this case, you will get the answer this thing, and without any surprises, if you pass 13 specifically, then also you get exactly the same thing. So that should be fine. But how this 13 is come on passing 13, why this so you can understand that when I'm doing plus 13, then why this thing is coming. When I'm doing plus 1, then why this thing is coming. So the idea is that you can clearly see that from A to B, how do you go from A to B? From how do you go from B to C? So you can firstly try to implement on your own, and then we will try to implement it here. Yeah, so now if you want to see the solution, then let's start implementing. So for now, for simplicity, let's not take multiple words, let's take a simple one word. So this S is a sentence, but rather than multiple words, it's just a word, one word. Okay. Now now when I'm passing this 1 and S, so let's pass S and N, right? That is fine. And for let's print this. So obviously we have got ABC, right? Now we have to transform it, right? Okay, so ABC has to be transformed to plus 1, right? So it has to be transformed to BCD. Okay, so what do we have to do? Firstly, you understand that whenever the continuous alphabets are going to be transformed to continuous numbers, continuous some other alphabets, then the very simple way is to convert it to numbers first, right? And how do we convert it to numbers? We convert it to numbers simply using char codes. Okay, now we have learned that how to transform char code to char codes and and get it back from char code to a particular character. That also we have understood, right? So if you remember, then we had something like this. So let's say const code is equal to, we can do something like uh, so okay, so let's say simply A is there and there is no small letter, so let's take capital A dot and we had char code at, and you know that if I don't pass anything, then by default it is 0, so it is assumed to be 0, so that is fine. And then you can print this code, right? So you can see that you are getting 65. Okay, fine. Now I can get I also know that from this 65 code I can also get back my A if I do something like string dot from char code, and in that if I pass this code, then I'll get back A, which is passed, from which the char code is created. Okay, so that is fair enough. Now we are dealing with just A. How do we deal with all the characters in the word? So right now we know that this S is not a S, it is just a word, W. We will see that how to do the whole sentence, but let's say only for word, how do we do that? Okay, so for words, for a particular character, we for a particular uh, word, it will have a few characters. Okay, and all of them will be definitely some alphabets, because we know that it is not a sentence, it is just a word, which means that there is no white space or something in between that. So if we do simply like simply like let's say w dot so let's simply print better. So w dot if we simply split by just empty space, then we know that we'll get an array of all the characters ABC, and on that now I can do dot map, and I want to do some transformations. Since the transformation might be slightly complicated, so let's simply write tr and implement that function tr, because I don't want to write the complicated some logic inside here for simplicity. And now you can see that yeah, now it is pretty much simple. So from here, let's say I return x, then everything will be mapped to x, understand? But that is not what I want to properly take that value, whatever the character is there, and then from that character I want to get the character code. So let's jump this thing to here, which means that now rather than hard coding A, I have got all the characters, right? Which means that I simply take C char code, and right now let's don't do anything, just simply create, let's do something like this. That what I did, I simply created, I simply took the char code, and again from that char code again I converted back to string. So essentially I have not done any transformation, but you can see that earlier also ABC was there, now also ABC was there, right? But now you can see that let's do this let. Now you can see that if I do code is equal to code plus 1, I could have done code plus 1 here also, but we are going to do a bit more here, that's why I am doing it in a separate line. But you can see that if I am doing code is equal to code plus 1, then what is going to happen? Now you can see that it is becoming BCD instead of ABC. And why is that? Why is that? Because my you can in fact print also the codes. So you can properly print that what is my C, and for that C what is my code, everything you can print, right? So you can clearly see that for A, B, C I am getting so A was 65, but my code, new code is plus 1, so 65 becomes 66, 67, 68. Now you can see, right? So that's why you are getting BCD. Okay, that is fine, but will it work for this thing? Will it work for XYZ? Let's try. You can see that X is becoming Y, that is fine, Y is becoming Z, that is fine, but Z is not becoming A. And the cause for this is this Y is 90, then Z is becoming 91. I don't want this to become 91. I want this to go back to 65, because A is 65, right? Capital A is 65. So how to do that? So you can understand what is happening is that this code is equal to code plus 1 is there, and earlier we saw that there is some sort of wrapping is there, right? So whenever this wrapping of things comes, then the first thing comes into mind is the modular arithmetic. We know that modular arithmetic, if let's say we do anything mod 5, okay, then everything will be in the range 0 to 4, okay. So even if again 5 becomes so after 4 if you become 5, then 5 mod 5 will be 0. If you become 6, then 6 mod 5 will be 1. So you can understand that the whole thing will be in the range 0 to 4. That is the point of the mod system, because it will just give you reminders, okay. So here, why don't you think something like this, that if I had something like this, that if A is 0, B is 1, something like this. If you try to think the whole alphabet like this, and let's say Y is obviously 24, Z is 25, and why Z is 25? Because there are total 26 alphabets, and the indexing is starting from 0. So the first one is 0, then the last one will be 25, the second last will be 24. So if this is the way, then it is pretty easy to do that transformation, right? If now if somebody gives you the value, let's say Z plus 1, and if that becomes 26, then all you have to do is that 26 mod 26, and now it becomes back to 0, so it becomes A. If somebody does Z plus 2, so Z plus 2, rather than going to beyond, what is happening, that 25 plus 2 will be 27, and now 27 mod 26 will be 1, and since this will be 1, then 1 means B. So you can understand that Z plus 2 will be B. So using modular arithmetic, turns out that it is working fine, and we can take advantage of that. But in order to do that, A should be 0, B should be 1, but right now our A is what, 65, B is what, 66. So what essentially what we have to do is that so let's do this transformation later. Right now I'm just printing it here. let's see this thing. This XYZ is fine. Let's start firstly with simply ABC. Okay, so you can see that A is 65, B is 66, C is 67, but I want A to be 0. Okay, in order to take advantage of this thing. So why don't I do something like this, that I have to subtract 65, but again then we don't want to be using this hard coding thing, right? So what is 65? 65 is simply a char code of A, right? So simply we'll do something like this, A dot char code at, this will be, I know that this is going to be 65, right? So automatically this thing is going to be 0. But then again when I do string dot char code from, then again I don't want to take do it from 0. While decoding, again I want to add 65, because 0 should become 65 if I want to transform. Okay, so the same thing I'm taking it again here, and you can see that I'm doing it again. So you can understand that ABC is becoming BCD, so everything is working perfectly, except that now code is not 65, 66, 67, rather it is 0, 1, 2. And now since this is in this range, so if I use this thing instead of ABC, if I use XYZ, then when I'm getting 23, 24, 25, till here it is fine. But let's see this. If I do increment it before, then it will become 24, 25 and 26, and this is not I want. I don't want it to go outside the 0 to 25 range, and that's why I should do mod, right? If I will do mod, see, code plus 1, rather than using code plus 1, I will use code plus 1 mod 26, which means that if it is going outside that range, 0 to 25 range, then again it will be wrapped in 0 to 25 range. So now 26 will become back to 0. If 26 will become back to 0, then this code will be 0, which means that for XYZ it will be not 24, 25, 26, rather it will be 24, 25, and then 26 will become back to 0. If this thing will become back to 0, then this thing will be not this square bracket, right? Why square bracket is coming? Because after Z, that thing is there. You can see in the ASCII table that from 65 all the way till 90 we have Z, and 91 is this square bracket, opening square bracket, right? And that's why this thing is coming here, which I don't want. I want A, back to A, and that's why I have done this modular arithmetic. If I do this modular arithmetic, then it will be back to 0, and you can clearly see this. Now this 26 will become back to 0, and now that is that wrapping behavior, that rotational transformation behavior is coming perfectly. Okay, so wherever it is not needed, so for example for ABC we saw that for ABC it is 1, 2, 3, so it is not needed, so automatically it is BCD, that is fine. But wherever it is needed, that wrapping is needed, that thing will be automatically applied, right? And again this is 1, right? If I do 2, okay, firstly I am doing 2, then am I using this 2? You can see that I am doing this hard coding of 1. So rather than that, let's use n, which means that whatever I am passing, 2 I am passing, then 2 I am using. Now you see that the transformation is plus 2, which means that A becomes 2, so 0 becomes 2, right? And now you can see that Y becomes 0, Z becomes 1, which means that this Y and Z transformation will be A and B. Okay, so now you can clearly see that A becomes C and C, D, E, and then X becomes Z, and then YZ becomes A and B. So that rotational behavior with our this thing is coming perfectly. Okay, so one small thing also, that if we don't pass anything, so let's say the transform, what did we say? We say that if nothing is passed, then 13 should be the transformation, right? So what is this? This is 13. So if 13 is there and we are getting this answer, then we should get the same answer. We should get the same answer for uh, even if we don't pass anything. But right now, if we don't pass anything, then obviously this thing will throw error, because you see that what is the problem. The problem is that n becomes undefined, which I don't want. So is equal to 13. If you do, we have learned this syntax, right? That if we write something like this, then in that function, if you don't provide anything, then automatically that thing, rather than becoming undefined, that becomes whatever after equal to. If you have provided 10, then it will be 10. If you have provided 1, it will be 1. But you have not provided anything, then it is not undefined, it is whatever you assigned, like this. This is just a syntax, it is not assignment, but yeah. So 13. So you understand that even if I'm not passing anything, still the same thing will happen, because now my default is also 13. You can understand NOP K LM is there, that is fine. Okay, so this transformation works. Still, one problem is there. You can see that if I put space here, so ABC space XYZ, okay, then see what is happening. See, ABC is transformed, but then a space is transformed to hyphen or something, right? In the same manner, if you see that simply use 1, then you can see that ABC and this space is transformed to semicolon, right? So space is transformed to semicolon, okay. Yeah, so let's see yeah, so that is what is happening. You can see that this is like this is not expected, right? This is not expected. We are this space thing is like this is not the behavior what we want, right? We simply want to ignore the transformation for spaces, right? So this is definitely not this is not what we want. So whatever is happening, we simply have to somehow not do that. Okay, how can we do that? Firstly, why don't we take this s, this whole thing, and split it into words, and then on each of the particular words we do the same thing what we did earlier, which means that rather than rather than doing this, so this w, this is now s, right? Now now we know that on w we can do this, but firstly let's take the words, let's say words, and words is what? Words is basically s dot split by space. If I do that, then I get the words, right? So firstly one thing, when I was doing simply let's only do w. So rather than giving you a proper simply array, let's give a proper answer, which means that ABC I want proper string answer, right? So let's give that, which means that whatever the transformation is done, so this map I got, but after that is an array, right? I want to join it, so I can join it with empty string, and then I will get so you can see that the arrow is different, and then you will get BCD. So now if we start doing the same thing with let's say ABC XYZ, let's say multiple words are there, then simply instead of word, I'm not taking a string, so I will simply get the words, right? But now this words is an array, right? You can print it down. So right now you can simply print this, and you can see that this each of the words is like ABC and XYZ, and we have already done the transformation for for that thing, for one particular thing, right? But right now we have to do for words. So again, firstly, why not we do something like this, that let's simply take the words, and then do a map where I will get each of the words. When I'm getting that word, then we will do that whole thing, this whole thing. So let's try to see that what it is. Let's say words is equal to, and you can see that my ABC becomes BCD, my XYZ becomes YZA. So essentially right now also you can see that we are using just one shifting, right? So that is fine. Now we have to join it, right? So we can simply do words is equal to words dot join. Now do we join? We split by space, so we join by space. So if we do this 3 lines, then now our words is again it is a sentence based structuring, and this is expected, as expected it is working, right? So ABC space XYZ, we are giving answer ABC, BCD space remains as it is, and then XYZ becomes YZA. So this is exactly what we want, right? So that should be fine. And now we have to simply return this words. We have to simply return this words, right? And then this is now, this is fine. This is fine, and now this thing is not needed. Okay, so yeah, that should be fine. So looks like this solution should work. So you can say that this thing is giving me this thing is giving me this. So A, when you shift by 5, then A to E, it goes to the next character, which is F, right? Again, if you don't pass anything, then by default it is like 13, right? So A plus 13 is what you can understand, that E is 65, right? So it will be 78, and you can see that this 78 is N. So that's why ABC becomes NOP. ABC becomes NOP. So it looks like it is working, right? So yeah, so let's test it on a few test cases. Yeah, so this is a few test cases. So this is a public URL which I'll give in the description, where a bunch of test cases is there. Let's use this test case for Caesar cipher. So essentially you can see that it is expected that if you are shifting by 2, then ABC, this thing should become something like this, CDE. If you don't provide any number, which means that by default it will be 13, and then that's why this thing will become NOP. This we already saw, right? And then we know that everything has to be uppercase, so we don't need to verify and do anything for that. It is if it is not uppercase, then it will be invalid input, so we don't need to bother. Every time in proper test case, only uppercase letters will be given. So now you can see that if nothing is there, then by default 13, it should be shifted by 13, right? And that is fine. If it is shifted by 23, then I should get this answer. So let's see if our solution works as it is for this test case or not. So let's see. So you can see that done, which means that no assertion error is there, which means that all the expected answers are exactly there coming from our solution. Okay, so that should be it for implementation of Caesar's cipher.